with the game scene the way it's been developed, if we simply save it, okay, by going to File and press Save Scene, and if we press the play button, you notice that the player is going to be hovering over the floor. Okay, it's not going to fall looking like this. Okay, there's no gravity being applied, but we're going to need this as we develop the game, both for the player and for the enemies that we're going to build. So to adjust this, we need to select the player game object in the hierarchy. And we're going to look at the inspector, because there's this important button here called Add Component. We're going to click on it, we're going to search for rigid body, and we're going to click on it again in the rigid body component, so it's going to be added. And you're going to see that you're going to have different fields here like mass, drag, angular drag, gravity. So, well, the physics are going to be applied now. And this time, if you press play, the player is going to fall. Okay, and this is great. This is something that we wanted. But there is something that we have to make sure is not going to happen. If we move the player to the sides, then there might occur that it's going to flip, okay, that it's going to rotate to some other directions. But this game is going to be very simple, okay? Even though it's 3D looking, it's going to have the two-dimensional spirit, okay, that arcade spirit of simple games and still addictive and very fun. So we're going to the rigid body component, we're going to click on constraints, and we're going to make sure that we want to freeze the rotation of this element. So we're going to freeze X, Y, and Z. So we make sure rotation doesn't happen. Okay, so this is the player. Okay, we have the script, we have the box collider for processing collisions, and we have the rigid body. But how do we make the player move? There are several ways to do this, and there are going to be several ways to make the player to perform movement. But in this game, and in other alternatives, in other variations of the game that we're going to build, the player is going to move based on whatever we are clicking in the window. Okay, this is going to be decisive to make the player moving properly. So if we click on the left side and we drag to the left, then the player is going to be moving to the left. Okay, so it might seem a bit complicated at first to make this logic, but it's actually not that complicated. Okay, so first of all, in the player, we're going to need a variable that is going to define what was the place that we clicked first. Okay, so here we need to type private vector2 and then click origin. Okay, so how does this happen? When we click in the screen, we're going to return coordinates based in the screen space, not in the world space. Okay, so for instance, normally you should be watching this in a mobile phone or a device that contains a resolution of 1280 pixels by 760, for example, just shooting out some numbers. So there's a two-dimensional space here. You have a certain amount of pixels horizontally and a certain amount of pixels vertically. When the player clicks in the window, then we need to make sure that we are going to track where the player clicked or touched the screen. Okay, it works on computers and on mobile phones. And as you move your pointer or your finger, we're going to compare what was the distance that your finger or your mouse pointer traveled. And with that in mind, we're going to communicate that to the player, what has been the delta, and the player is going to move to that direction, okay, to where we are dragging our finger to. So this is going to be the important logic here. And we want to have that click origin variable here. And in the start method, we want to set that click origin to be simply 0. So you can type click origin equals to vector2.0. And now, how do we get where we are clicking? Okay, how do we get the coordinates of where we are clicking? Here in the update method, we're going to make a very simple test. We're going to type debug.log. So we're going to print message to our console, and between parentheses we're going to call the class input, then mouse position. Okay, so as you see in the summary, it says the current mouse position and pixel coordinates. So we're going to print input.mouse position. Okay, so let's save this, let's go to Unity, we're going to wait for the compilation to complete, and after this is done, we're going to go to the console window. You can ignore this warning for now, we're not using the click origin just yet, but that's okay. And if we press play, you're going to see that you can get where the mouse is. Okay, so this point here is the coordinate 0 on X, okay, and if you move up or down, it's 0 on Y as well. Okay, so here is pretty much the beginning of this vertical of this two-dimensional space, and here is the end. And here is a catch that lots of beginners do. There's a problem with this. Okay, if you get the distance just by using these pixels, okay, just using this as 0 for x and this as 445 for the right limit of the screen, and you simply use the distance using these units, you're going to have a big problem, okay? Because devices with a lower resolution rate are going to behave very, very, very differently than devices with a high resolution. So, for instance, a 4K mobile phone, for example, would make the player move much faster than a very simple phone that has a resolution of 600 by 400 pixels, for example. So instead of using these values directly, instead of simply getting the coordinate of where we are hovering our mouse, we should get the percentage of the screen where the mouse is or where your finger is. This is very important, and it saves you a lot of trouble. Okay, so what we want to do is, instead of simply getting the position, we want to know what is the percentage of the screen where we are touching. So to test this here in this update method, here's what I'm going to do. I'm going to put the string x, then a comma, and that space plus input.mousePosition.x. Okay, I'm going to print the position in the x-axis. Now we can copy and paste this line into the same thing for y. So y here and y here. And here's what we're going to do. We're going to enclose both of these input calls between parentheses, okay, like this. And in the x part, we're going to divide by screen.width, okay, and here we divide by screen.height, okay. So if x is the minimum value possible, which is 0, this is going to return 0. Okay, if it's half the screen, this is going to return 0.5. If that's the if you're in the complete limit of the screen to the right, then this is going to return 1. And these percentage values are great. Okay, it's going to simply vary between 0 and 1, and that's independent of the screen size. Same applies for y. If you're touching the bottom of the screen, it's going to return 0. If you're touching the top of the screen, it's going to return 1. So this time, if we save and we go to Unity and wait for this to compile, we're going to press the play button. Okay, so here we are, and we're getting the values of x and y. Okay, as you see, if we move to this part of the screen, okay, almost, I can't move precisely there, but you're going to see that x and y are very close to 0, and if we move here, they are very close to 1. Okay, if we put the pointer in the exact places. Okay, just check the console to see the values that are being printed. Okay, so with that in mind, we can already work on a logic to see how much our pointer has traveled in the screen, and we should be able to also tell what has been the delta of the movement, so the variation of the movement.